All right, so for the bell work, I'm not going to walk around. You're getting an exit ticket today, so that'll really be great. Again, you're going to have two graphs where you have to graph it. You got to figure out, how do I graph this problem? How do we do that? We've done it 3 days in a row, well, 3 class periods in a row. You should know that without even looking, really, but you have it somewhere. Make sure you find where that is so you can do it on the exit ticket. How do we tell which method to use, which basically means, do we use the yellow sheet or the white sheet?
F5 by itself.
You are looking for the variable. So here's an inequality. Doesn't matter if it's an equation or an inequality, it's still the same thing. You're looking at that inequality or that equation, and you're finding the y variable. If that y variable is the only thing on that side of the equation, if it is the only thing, so again, the sides are still split up by wherever the symbol is, the equal sign, the greater than, less than, whatever it is. If it is the only thing, like in this problem, there is nothing else on that side. And it doesn't matter if it's the left side or the right side. If it is the only thing, then you use the yellow sheet. That is slope-intercept form. So we're going to have a slope, we're going to have a y-intercept, and then we follow the yellow sheet process. I, again, encourage you to pull those out by doing that and then that. So go ahead and write them out. This is not up here, but how do we find the slope from the equation or inequality?
So it is going to be, wait, can I?
Yeah, that's fine. We're doing this in free class.
So it's going to be the coefficient before x.
So whatever's directly in front of the x, like attached to the x. Really, it's being multiplied times the x. But in this particular case, right in front of the x is the 4. What do you need to be careful about?
You need to
Not in this problem in general. This problem doesn't have it.
Oh, if it's a negative or a positive.
If there is a and this is for every number you see in an equation. Every time you see, again, what you probably consider a subtraction sign, that is really a negative sign. I wish we would have never come up with subtraction. We would have just added negatives for everything. That would have solved this problem. But we didn't. So this negative sign, every time you say the number 3 or you write the number 3, you should be writing that negative sign in front of it. Now for 4, it's positive because there's nothing in front of that. We don't look at what's behind it, by the way. Some people are still looking at what's behind it. It's what's in front of the number. There's nothing in front of that 4, which means it's positive. All right, so make sure, because again, with graphing, that one little thing costs you a bunch of points if you forget that negative, because negative 4 is a different number than positive 4. I can't give you partial credit for that, which is wrong. All right, so if I pulled it out, that would be the slope. That would be the y-intercept. Again, negative 3. What would I do next? I'm not going to graph the whole thing, but just real quick, what can we also do really quickly?
So you would put the 4 over 1.
Yes, the step 2 on your yellow sheet says if we don't have a fraction for the slope, which we don't, we just have 4. We don't have a fraction, we're going to need a fraction later because we need a rise and a run number. So we just put it over. So that's what step 2 means. If you don't understand the wording, you need to put your own words right now by step 2. It just means do that. Now, if we already had a fraction, like we already had 1/3 or 1/2 or 3/2 or a fraction, we wouldn't do this. We don't need to put it over 1 then. We already have a fraction. We just need 2 numbers, a top number and a bottom number. If you already had that, you don't need to do it. And then next to that, the third step, we would write rise over run so that we know, not a very good run word, but so that we know which numbers are rise, which numbers are run. Don't skip that step. Because way too many people are going the wrong directions. And then the other thing was we had written down like positive run, go right, negative run, left, positive rise. I'm doing the short version, it means go up. Negative rise, you should have that hopefully on your low sheet too or somewhere. Negative rise means go down. So if you have all of that stuff in one place, I mean, you should by now be able to follow the directions on that. You're going to practice it a little more today. It's the front sheet of that worksheet. Real quick, number 2. Is the ordered pair 0, 0 a solution to that inequality?
Yes.
How do you know that? What do we do to check? If you get a question like that, what does that mean? What do you do? Nick?
Given the numbers.
Yeah, you just plug it in. Just plug it in. That's all that means. It means, well, if that's a solution, when I put this is an x, that's a y, when I put those values in for x and y, it better make, in this particular problem, it better make the left side less than the right side. That's the rule for that problem. If it does that, then yeah, it's a solution. If it doesn't do that, it's not a solution. That's how we determine which side to shade. I didn't actually shade anything for this one. We're not graphing that one, but that's the last step of graphing inequalities is to plug in, and I always say use 0, 0, but you can use whatever you want. Plug in 0, 0, do the math. We would come up with 0 is less than -3. And then we would say, is that true? 0 less than -3. No, then 0, 0 is not a solution, which means we would have to shade the other side of the line, not the side with 0, 0. I'm going to redo a problem we've already done and show you the shortcut to that real quick. I hate shortcuts, but I'm still going to show it to you. All right, any questions on that? I'm going to do reviews, but mainly for people who weren't here. I'm going to redo one slope-intercept graph. So you've already done this one. Oh, I guess I could create a, here, tell you what, if you have a blank set of graphs, I'm not going to pull out one, but like, you know, those, I give you those blank graphs sometimes. If you want to pull one of those out, if you really want to grab one, if you don't have it, it's the top papers on the stack. You should have, like it's the one with 4 graphs on it. Yeah, that would work. That's not what I was talking about, but yeah, can I show that real quick? This is the one. Yeah, the 4, this. I've given you, I don't know how many of those. You probably have a blank one on one of the pages I've given you if you have all your stuff. Pull that out. Again, if you don't have one, you can grab one. It's the big stack up top at the very top page. All right, so I'm going to create a new equation that you can try to do on your own. Again, this is just practice for the exit ticket. It's going to be y all alone, which means we're going to use which sheet?
Yellow.
Yellow sheet. What do I want to do then?
Put a negative in.
Definitely going to put a negative in. Let's do, I'm going to do this version. Actually, no, I don't want to do that. There, try to graph that. So again, there's 3 steps to graphing an inequality. The first step is you have to get the first 2 points on them. That's the whole yellow sheet or the whole white sheet, depending on which type of equation it is. Then once you do that, step 2 is what for inequality? Well, you have to check.
Is the line solid or that?
Yeah, that's an easy one. Like, is it a solid line or is it a dashed line? All you got to do is look at the symbol. So nobody should mess that up as long as you remember to do it. And then the last one is figuring out which side to shade. So we'll do this one real quick. And then we'll do one example with standard form. And then you'll just practice the exit ticket. I don't think the exit ticket's going to take long, so I'll probably just give you 15 minutes on it. You only have to graph 2, and then you have to answer 2 questions. If you're done, just kind of put your pencil down so I can kind of gauge when people are finishing. Did anybody in here ask me if I had a notebook? Like, you know, a notebook you can take notes in? Somebody asked me actually.
Wait, this you were number 2?
The one in red. Y is greater than 3, subtract 2x. First step again, I would do this. Write M equals and pull out the slope. Write B equals and pull out the line-intercept. Bless you. Again.
Thank you. It's actually my allergies, dumbass. Oh my god.
I don't think sneezing is really something that's really good. I think sore throat, coughing, loss of taste,
Yeah,
throwing
fever
up.
and stuff like that.
Yeah, it's the more serious things.
Do we do this on a paper that I already passed up on, or we just do it on a regular?
Yeah, I said if you have one of these, although you don't really. Oh wait, you got one right there. Yeah, do it on a blank graph. Oh, and here. I just saw these on my lap.
wants to shade the sign?
Yeah, that's the problem. If you see an inequality, oh, that's another thing. I'm glad you said that. Kind of like the big quiz was,
Something that just messed this whole thing up.
if I don't tell you whether or not you need to shade, you need to be able to figure that out. Am I going to have to shade after I create a line? Well, that's based on the symbol. If it's the only time you don't have to shade is it's an equal sign, like just an equal sign. If it's any of those other four symbols, this, less than, the less than or greater than, the greater than or I'm sorry, greater than or equal to, less than or equal to, any of those involve shading. Only the equal sign means you just put a line. And you need to know that on your own for the state tests and stuff. Maybe another, looks like a lot of people still working, so I'll give you another minute. Here, are you working on it? Let's do that. Yeah, but that, I think looks good so far, but you're not done, right?
Yeah.
Done? Holy cow, you got nothing.
Yeah,
You got it. No, you figure it out.
wait. It's a review.
Tell me what to do.
Okay.
Well, I'm not.
After I changed it to the I did the slope thing instead of fractionalize it. I got put everything out.
First of all, you need to put the right slope. Right now, you got it wrong.
I thought the slope was oh man.
There you go. Be careful.
I didn't see it. Okay, now that I have it right, then what do we do from there?
I just shaded it.
I got the same thing. Well, actually here, that's the wrong thing too. What's in front of the X? The equation in front of the X. That's in front of it, but that's the slope. And you will read X. It's not what's on the left, it's what's in front of the X. That's why I intentionally wrote that problem the way it is, because some people are still picking the first thing for the X, for the slope, the second thing for the Y-intercept. It depends on the order. Sometimes the order will be like that, sometimes it won't. You gotta remember the slope. So here's what I want you to do. You see where it says slope? Circle that. And then like make a little arrow and just write in this blank space, write the number in front of the X.
Oh, thank you.
That way you'll have that when you see a problem that's in a different order. You need to write the slope and the y-intercept. This is not, that's not,
Oh.
you just plotted 3 and -2 or -2 and 3 of them. You gotta, that's not how you do that. So I'm gonna go over it, but you need to take some notes on it. Again, I can't go back and redo the entire lesson on this. You guys, we've done this for weeks and I know you missed some class, but again, you're responsible for watching videos and catching up. So there's only, I mean, we got a whole nother type of graphing we haven't done yet for review. We gotta do the standard form. So I'm gonna do this one fast, but again, I can't reteach it for you guys that are just now trying to figure it out. So slope is this. This is slope. So this goes there, that goes there. And then I'm gonna redo it. So yeah, so that would be, yeah. So that would be it. Now this, I mean, I guess that's fine. If you're putting it there, that is the right spot. I've been teaching the run, because technically the run is +1. So you would go right 1 and then negative right would be down 2. You got it right. So as long as you make sure you're, I don't even know how to explain that. Again, you did get it right, but that's not the way we learn it. So as long as you keep doing it correctly, that'll be fine. But that will not, put it this way, that will not follow what I wrote here. What you did doesn't follow this. So if you're not using that, you got your own system, I'm fine with that. But this, just don't get confused. Don't try to use this because it's not going to match up with what you did. That would have put the dot to the right hand down, which would still work. So this is slope, that's y-intercept. Forget which one's which. There they are up on that board, but also the slope is the number in front of the x. Do you not have a yellow sheet?
I do.
Okay, well, I have that out. Perfect, yeah. So you make that negative, put it over 1. So now from there, you know what your run number is. Do you have, I would write, you have that positive, yeah, I would write either probably on the yellow sheet, this little section right here. And that'll tell you which direction to go now that you already have the fraction created right correctly. Okay. So now that you have the fraction created correctly, if you either write it on the yellow sheet or you can write that sheet, doesn't matter. You have the run, I think is positive, right? It's +1. So you'd go, that means go right. If you need to write in the words what that means, go right. Then you have a negative rise, I believe, correct? -2, I think. So that's telling you to go down. So you count right and then down. And then now, so now you're on, you have the steps that we, yeah, so here, now you're on this step right here. Is that line, so you're gonna draw a line between those points. Is that gonna be a dashed line or a solid line? And you don't have the last part of that, so I'm gonna put it back up. This is how you tell if it's dashed or solid. If it's one of those two symbols, it's solid. If it's one of those two, it's dashed. So I would write, like draw a little line somewhere from the second step and then show that that's how you do the second step. All right, I'm gonna go ahead and do it. So those of you that were waiting for me to check, just check it along with me. If you don't have it correct, ask questions. You have it wrong, you don't understand why I do what I do. When I do this, now's your time. Don't wait until the exit ticket.
Then you're gonna fail.
Well, again, it is an exit ticket, so I'll help a little bit, but I can't sit there and do the whole problem with you during the exit ticket. This is the time where you try to learn it. I'll answer maybe 1 or 2 questions for the group.
Is the exit ticket the only thing
Well, practicing for the exit ticket, yeah. There's no, I mean, because we've already done graphing, the only thing we're adding in is the shading part really in the dash or the solid line, which is a little difficult to do. Then yeah, we don't have a whole lesson or anything. So these were the 3 steps for inequalities. We just did, I hope you just did the first step at least, putting the first 2 points on there. So now we've got to, and I'm going to do all of those steps. So the, what was the slope?
The slope was
-2. It's what's in front of the x, and don't forget a negative sign is glued to the number that follows it. So it's -2. So that means the number all by itself, the 3, is the y-intercept. So it says the first step, put a point on the y-intercept. So there's our first point. Now it says we need to have a fraction for the slope, which we don't. So we do what?
You put a 1 under the 2.
Put that, which I think most papers I saw, we were good there. Some of you did have the wrong slope and wrong y-intercept.
Ain't it supposed to be 3? Like that would go up 3.
Oh yeah, I don't know why I put it on 1. Totally just stared the 1 down.
And then you go over.
Oh, because I was thinking about putting the 1 there, so I had 1 on my line. So it's on 3. I think most people were fine with that. So now I need to do the rise and the run thing. I do that in a whole separate area. If you just want to write it next to that, that's fine, but don't skip that step. Don't just think, oh, I know which one the rise is and the run is, because ultimately that's when people start to mess up. It's when they skip steps. So I'm going to write that down. I'm going to pull my fraction over and say, well, that's my rise number. That's my run number. Now, if you've got this stuff written down somewhere, you're pretty much good to go. It tells you which direction to go. A positive run means I'm going to go right. That's what that arrow means, right? So right 1. Now I still am waiting here to see what I do. So now I look at the rise, which is negative. Well, that says go down. So 2, so I go down twice. So there's my second point. From there, the second step's pretty easy. You should have this written down. If you don't, second step, it just says, well, if it's one of these two symbols, make it solid. If it's one of these two symbols, make it dashed.
Yeah.
So this symbol is one of these two, so it's going to be dashed. What does the dashed line mean?
Dash line mean those are the
Why are we making it
instances
dashed?
If it was like a regular equation, like slope intercept form.
That's a good question.
It's like
Mm,
it's the answers that won't work for this.
so that's getting pretty close to it. So I'm making it dashed. So that's a dash. That's not the way I normally do a dash line. So I made a dash line. Why isn't it solid? I mean, I know it's not solid because I have that symbol, but why does that symbol mean it's not solid?
Because if you plug one of those points into that inequality, it's not gonna make it true.
What's it gonna do?
It's gonna make it to where that side isn't, or y is not gonna be greater than 3x.
What's it gonna make it? What's it gonna make it?
It's gonna make it less than.
Almost said it. That's it. Every point on the line, always, whether it's dash, solid, whether it's an equation, an inequality, every point on the line always makes the left side equal the right side. Well, if we don't have the little equal sign under here, then that's not a solution. Points on the line always make the left side equal the right side. But in this particular problem, we don't want the left side equal the right side. It's got to be greater than. So now these points on the line are no longer a solution because it's going to make everything the sides equal, which is doesn't work. That's why it's dashed. If this was there, well, now we're okay if the left side equals the right side because of that little guy there. So that's why we would make it solid. Again, that's very conceptual. If you get that, that's fantastic. If not, you can get by without it. So now we have our dash line. We need to figure out which side to shade. We said, let's pick a point. I pick any point on the graph. I always pick 0, 0. It makes my math easy. So if I plug in 0 here, 3 subtract 2 times 0. Well, that just gives we're going to come 3 subtract 0 on the right. So is 0 greater than 3? Because 3 subtract 0 is 3. No, absolutely not. So 0, 0 does not work. That means nothing on this side works, which means I've got to shade this side. So now I'm going to give you a shortcut. So when this is only, so before I give you the shortcut, you need to write this. This is only for when y is by itself, the slope-intercept form version. This does not work in standard form. No, what I'm about to tell you. So you need to make sure you understand. This is only for the yellow sheet, only for when y is all by itself, only for slope-intercept form. If I just look at the symbol, it says greater than, right? For this type of problem, the symbol is all you need to know on which side. You don't have to do any math. You really don't even have to plug in anything. Because I just need y to be greater than this, which is really, this is really the line. That's the line. That whole expression represents the line itself. I need y, my y value, to be greater than where the line is. Anybody understand that?
Yeah.
No,
Aiden, do you understand that?
I don't.
Changing the music? What are you doing? I see the earbud and the phone. What'd I just say?
You were talking.
I was talking.
Yes.
It's good that you recognized that I was talking. I said that's good that you recognized I was talking. What'd you miss? Because this was the shortcut. This is why phones are a distraction. Were you on your phone? That's why you can repeat it.
No, but I was like, I'm sleeping.
Actually, sometimes I don't mind. Like closing your eyes sometimes helps you focus on what I'm saying. Like, a lot of times when I'm listening to something, I'm closing my eyes. That's exactly what I'm talking about right there. Absolutely.
Could you do like an example of what you were?
I'm going to, but we're waiting on Aiden right now to give us.
You were talking about on how if you
I got
plug
it.
in zeros, like for.
No, I said you don't have to plug anything in.
What?
I actually said you don't have to plug anything
You just have to
in.
recognize that your Y is the line.
So now pay attention because here's the shortcut. The Y, so this expression, so the right side basically, that really is the line. This is what the line is made up of, our y-intercept and our slope. I just need the y, which is kind of like the answers. I need all the answers to be greater than the line, because that's what the symbol says, right? Greater than. So all I need to do is go where the line is, any point on the line, go higher, because that's greater than, right? If I'm here, this is a y value of -3. I just need a y value bigger than that, which means go above the line, and I shade above the line. That's all you have to do. So here's the even shorter version of that shortcut. If the symbol says greater than, you shade up from the line. If the symbol says less than or less than or equal to, same thing, you shade below the line once you have the line. So if you should have already done some of these. If you haven't, we'll be practicing. Look at your paper. If you have a greater than symbol for ones you already did, you better have shaded above the line. This is how I was actually checking it when we did it last class. I was just looking at the symbol. So you should have shaded above the line if the symbol was greater than or equal to. If the symbol was less than or equal to, you should have shaded below the line. Now, sometimes when the line's really straight up and down, it's hard to tell. It looks more like right and left. Again, just pick a point on the line and go up. That's above the line. Or pick a point and go down. That's below the line. And that's, depending on which one you're supposed to shade, that's how you determine the shade. So I can just tell you real quick, and that only works when y is all by itself, so it wouldn't work for that one. I can tell you right now, well, that's a less than, so I need to shade below the line once I have the line. That's a less than, I need to shade below the line. So again, you can check your answers. You should have already done some of these. This is a greater than, I should shade above the line. This is a less than, I should shade below the line. Only works when y is all by itself. So as you're doing this today, you can kind of use that to help you confirm that you're right. Now though, we got to do standard form real fast. I'll go ahead and do one for you. You can pick it. Which one do you want? This is actually more slope y-intercept, by the way. I don't know why it's on there, because y is all by itself. I don't know why they put it on that one. 7? Oh, first one. All right. So, I think, I mean, they're all the same, really. Right? Number 10?
Yeah.
All right, so let's take a vote. Raise your hand for number 7. Quick. Raise your hand for number 10. 10 one. I mean, it's all the same stuff, really. All right, so this is the process where we plug in it. So it's the white sheet that says steps to graphing in standard form. It's the process where we're going to take 0, say, what if x was 0? What would y need to be? Well, we're going to figure that out. It's the process where we say, what if x was 0? Because remember, I can come up with any value of x and y that makes this a true statement. Any value. This is standard form. First, though, we got to come up with 2 points that would be on the line, where if the left side were equal to the right side. Because we've always got to have a line first. Because that's kind of like our determining point of which side works and which side doesn't work, is the line itself. So we got to figure out all the points where the left side equals the right side first. Then we figure out the shading based on what the symbol is. So I don't have y all by itself. I can't do slope. There is no slope. There is no y-intercept if y is not by itself. Not the way it's written right now, at least. You could change it and come up with it. So what I do is I say, well, what if x is 0? What if x was 0? What would y need to be to make the left side equal the right side? Because I can figure that out. Yeah, and it's not even that bad of math on most of them like this. So what would y need to be? Well, let's figure it out. If x was 0, I wouldn't need x anymore. Remember, once you know what a variable is, you don't need the variable. The variable is an unknown number. So if I'm making x equal 0, I don't need x anymore. So I plug in 0, subtract 5y. I know, I heard it too. I ignored it. So then, if you just ignore them, eventually they go away. So that might be for something else. So 2 times 0 is what? Boy, I hope nobody says
0.
0, not 2. Way too many people say 2 or
That
1 or
is
something like that. 2 times 0 is 0. 0 subtract 5y. Boy, you guys make fun of it, but you'd be surprised at the answers I get. So 0 subtract 5y is negative 5y. 0 subtract anything, unless it's a negative number, I guess, is just that same number left over. Negative 5y. So now I have negative 5y.
How did you get negative 2?
Oh, him. He thought I said negative 2. I think that's what he said. Now my last step is divide. Oh, make sure that negative sign is glued to that 5. There's another situation where if you forget about that, it gives you the wrong number. Again, that is not a math mistake. That is a process mistake. So I take off a lot of points for it. If it was just a math mistake, I don't take off that much, but that's not math. That's using the wrong number. So divided by negative 5. Again, if you divide by the wrong thing, that's using the wrong number. That's a process mistake. Math just means you wrote the right thing, but then you came up with the wrong answer. So now I get y is, now technically we're supposed to, I guess I should show you this. Remember, when we divide by a negative in an inequality, technically we flip the inequality, so it really becomes y is greater than or equal to negative 2. That doesn't matter, because all we're doing is putting a point on that. We're not drawing anything, we're just putting a point. So the only symbol we're going to use is in the original equation, so that one doesn't even come into play. So that's where y is negative 2, right there. Really, this point is 0 comma negative 2, because we made x 0. So it's an ordered pair that is 0 comma negative 2. Again, that's what that point is. I just put on the graph 0 comma negative 2.
Dan thinks he's smart because he got the number.
He's a very confident man from what I hear. You know, we teachers talk about you guys all the time with each other. How's so-and-so doing in your class? How's it going for you? Are you doing this? Is she doing this? Is that on their phone on? Oh, yeah. We always say. So if you're acting up in one class and not another, we know. Now, what was the equation? 2x. Oh, so now I'm plugging in 0 for y. So I'll have the 2x now. But I'm going to make y equal 0. I'm saying, what if y were 0? What would x need to be?
2. Or I meant 5. I meant 5.
He meant 5. So now that would just be 2x subtract 0. Well, 2x subtract 0 is just 2x. Last step is I need to divide by 2. So x is less than or equal to 5. Again, the symbol doesn't really come into play because I'm just putting a point on that spot where x is 5. And that is my second point. So now I've done the first part of graphing an inequality. I have my 2 points. What's my second part for inequalities?
Now you have to decide what type of line it is.
Yeah, I need to check the symbol, which really you can check the symbol at the very beginning, in all honesty.
And that's
That symbol tells me to make it what?
solid.
Solid line. Right, so that is a solid line. It's got the little equal to part underneath it. So I'm going to draw a solid line underneath. So there's my line. So that's my second step. My last step. Again, I cannot use that shortcut. That shortcut doesn't work. I can't look at the symbol and just say I need to shade below the lines. That doesn't work when you have a standard form. So I have to plug in 0, 0. Well, I have to plug a point in. Again, you could pick any point you wanted. I could pick 2 positive numbers like 5, 5, 1, 1. But look at how easy your math is going to be if you plug in 0 and 0. 0 times this number is going to go to 0. 0 times that number is going to go to 0. The side with your variables will always just be 0. always in standard form. So you really don't even have to do the math. You just look at the side where the variables is and say, okay, that side's going to be 0. So if I'm testing this point, again, I'm really plugging in 0 for each number, so I'm going to do it. So like I said, this is 0, that's 0, the whole left side just goes to 0. Every time. That's going to happen in standard form. Well, depending on where the variables are, wherever the variables are. Is that true?
Yes.
It is, right? So that means 0, 0 is a solution. Now what do we do then?
So now you shade the top.
Yeah, so if 0, 0 is a solution right there, then that's the side we shade. Wherever the side is that has the solutions. Because remember, every point in the shaded region is a solution. Well, that means that we have to shade this side because we know that point is a solution.
Wait, this is a question.
Mhm.
So after you figure out that you go on the graph, then
The first 2 points you're talking about?
yeah, the first 2
All right.
points, then you do that right there, the 2 points.
Well, then you have to figure out is the line solid or dashed. So these are the
That's how we do
steps.
that, like
Yeah, you
that.
copied these down hopefully the other day.
Yeah,
these.
I copied all that.
So first we did the 2 points, then you have to say, okay, is the line going to be solid or dashed when you have the 2 points? Because you got to draw a line through them. Well, that's just based on the symbol. Then the last step is shading one side, and that's where you're plugging in 0, 0. So if you need to write that note after step 3, plug in 0, 0, then write, I didn't write it here, but you could write in plug, because technically you can plug in whatever you want. It doesn't have to be 0, 0, but, or you have the shortcut you can use for the 1 when y is all that stuff. So I'm going to leave this page up since this is really what today's lesson is. Go ahead. If you want to practice some on the front sheet, like review that, since that will be on the exit ticket, then you can come to this sheet and practice.
There's only one standard form question.
There's one, well, there's only one you have to graph. Although you really don't have to. The fact that I ask you, there's 2 graphs where I ask you questions about the graph. Really, whether it's standard form or slope intercept doesn't really come into play with the question I ask. It's not really about that. I don't like asking you which method is this or which way you need to graph it. I ask you something else. It doesn't really matter. But you do have 2 where you have to know which method you use to graph. Yeah, that's what I thought. Is that your question too?
Yeah, but I should go.
All right, you run real quick, and I'll work with Nigel, and then when you get back, I'll work with
Wait,
you
I
to
have
make
a
sure
question.
you're.
That was my question.
Oh, that was your question.
Yeah.
So this is the question exit ticket?
Yep.
So that means if we get one wrong, we're already at this.
No, you can get some partial credit on this. I will say though, graphing them, you could still lose quite a few points on the graphing. So make sure on the explanation questions, it's easier to give now, unless it's all wrong. Like you have no clue, like you totally get the explanation wrong. Yeah, you're going to lose some points. But on the graphing, that's the one where
It hurts the most.
you could, even if you're kind of getting it, you make a silly mistake with a negative sign, go in the wrong direction. It's still hard to get partial credit on that stuff. So make sure you, like you may just want to take notes on, don't make these mistakes. Like a negative sign in front of a number stays with a number. Make sure you have, although I don't think it's on this page, but yeah, make sure you have that positive run means go right, negative run means go left. Like make sure you have that stuff down or somewhere written where you can use it. Because those are the kind of things that could cost you points, even if you kind of know what you're doing. I'm going to stop the recording real quick, and then I'll walk around.